Okay, so finding a point of intersection of a line and a circle, quite a common question when dealing with coordinate geometry of the circle. So we've got our equation for our line here, and then we've got our equation for our circle here. What you can notice is we can't do a normal simultaneous equation in this case because we're dealing with two different types of variables. We've got x's and then we've got x squareds, and the same for the y's. So they're not going to be the same, so we can't cancel them out like we normally would in a simultaneous equation. So what we have to do is be able to sub in an x value or a y value into one of the other equations to solve for that variable. And then by subbing that back into one of the other equations, once we know the value of it, be able to then find its corresponding other coordinate. Okay, so what I'm going to do is I'm going to firstly look at my line equation, and I'm going to formulate it so that I'm getting one of the variables on its own. So for instance, in this case, I'm going to go with, sorry, that was a minus. I'm going to go with my x coordinate. So what I'm going to do is bring everything else over to the right hand side, so it's going to be x is equal to y plus 3. Now, once I have that, I can then sub that in for everywhere I see an x value on the circle equation. So it's x squared plus y squared is equal to 9. So I'm going to sub that in, so it's going to be y plus 3 squared plus y squared is equal to 9. Now, y plus 3 to be squared, so that's y plus 3 multiplied by itself. So write that out as y plus 3 multiplied by itself, y plus 3, and keep everything else the same, which is the equal sign, equals to 9. And then we split and repeat this, so it's going to be y plus 3 multiplied by y plus 3. And then still carrying down my y squared and my 9. So multiplying this out, then we're going to have y squared plus 3y plus 9 plus y squared is equal to 9. So at this point now we're going to tidy this up. So all the variables are going to match. So we're going to have y squared and y squared. So that's going to give us 2y squared. Our 3y and our 3y, that's the same variable, so we can add them together. So it's going to be plus 6y. And then what I have is plus 9 on the left-hand side and plus 9 on the right-hand side. Now, we want to get it so that there's a 0 on that right-hand side. So what I can do is I can bring that 9 across the equal sign, in which case it's going to become a minus 9, and that's going to give us 0 on the outside. So we can tidy that up even more. So it's going to be 2y squared plus 6y. Plus 9 minus 9 is going to give us 0, so we can leave that and just have is equal to 0. Now, normally when we get to this point, we would have a quadratic trinomial. So we'd have a y squared plus or minus a y plus or minus a number. In this case, we've just got the y squared and we've got the y. So instead of factorising using a quadratic trinomial method, we can factorise out what's common. And what's common to these two things is 2y. So what's going to be left then is going to be y, and then what's left for the 6y is going to be plus 3. Now, at this point, we're still looking to find what y is. We're solving for y at this point. So what we can do is we can let each part is treated as if they're two brackets, and we can let the 2y equal to 0 and the y plus 3 is equal to 0. So we're separating it out so we can solve. 2y is equal to 0. Anything equal to 0 is going to be 0 whether we multiply or divide it. It's always going to be equal to 0. So in this case, we're going to have y is equal to 0. On our right-hand side, we've got y plus 3 is equal to 0. If we bring that 3 over to the right-hand side, it's going to be y is equal to minus 3. So now we have our two y coordinates. What we need to find is their corresponding x coordinates. To do this, we need to go back up and have a look at our two formula that we were given. We're going to sub in the y coordinates that we found to find the x coordinate that matches. So we can use either of the two equations that we've got here. So we can use our line equation or we can use our circle equation. The easier one to use is always going to be the line because we're not dealing with squared numbers. So I'm going to use my x minus y minus 3 and I'm going to sub in my y value. So if I have x minus y minus 3 is equal to 0 and I have x minus y minus 3 is equal to 0 on this one as well, we have to make sure that we're going to use both y values. So if I have x minus, I'm going to sub in my 0, so 0 minus 3 is equal to 0. That's going to give us x minus 3 is equal to 0. And then I have also got x is equal to 3 from that, if I bring that minus 3 over to its far side. That means one of the coordinates is going to be 3, 0, as our x value is 3 and our y value is 0. To find the other one, I need to do the same thing with our y value being minus 3. So I've got x minus y minus 3 is equal to 0. So I'm going to sub in my minus 3 for y, same way I did in the previous question. Minus 3 is equal to 0. Now, in this case, we're dealing with a minus multiplied by a minus, which is going to give us a plus 3. Minus 3, which is equal to 0. X, in this case, plus 3 minus 3 is going to give us 0. We don't need to write that in, so it's x is going to be equal to 0. Therefore, we've got a point which is 0 minus 3. So our x coordinates is 0 and our y coordinates is minus 3. So these are the two points of intersection where the circle and the line intersect.